Okay, we're going to look at rational functions again, and we're going to solve for an unknown. This time it's just an inequality here. So we have our two rational functions on different sides of our inequality. And you decided that you're going to move our function on the right over to the left-hand side of the equation, which is great. So that'll leave us with 1 over x minus 1 subtracted by. And because technically this is negative 1, and you can think of the entire function itself as being negative, so that when it comes over, it ends up being positive. So we have 1 over x plus 2 less than and equal to 0. Okay. Now, in order to add two rational functions, we need the denominators to be the same, which means essentially we're going to multiply the first function by our x plus 2, both the top and the bottom. Okay. I'm just going to put those two in brackets so we know what we're multiplying. And the one on the right, we're going to multiply by the opposite denominator, which is our x minus 1. And let's see if I can squeeze it in here. X minus 1. When we do that, we'll still have our right side of the equation still 0 here. And on top, we're going to have x plus 2 divided by, might need a little more room, x plus 2 times x minus 1 plus x minus 1 divided by, should have made myself more room, x plus 2, x minus 1. Okay, what's good about this is now we can add the two rational functions together. Our denominator is going to stay the same, and we're just going to add the functions on top. So we'll get x plus 2 plus x minus 1, okay, and that will all be divided by our x plus 2, x minus 1, and still less than and equal to 0. Okay, less than and equal to 0. It looks like I have values on the top and the bottom here, and I could maybe distribute. I'd end up in standard form. It might not help so much.
Can you multiply the 0 by the bottom?
Yeah, we can do that. And essentially what's going to do is really just eliminate this. So we're only working on the top. Yeah, and the idea is that if we're dealing with 0 and we have a rational function, essentially, anytime we get a 0 on top of a rational function, so anytime we divide something by 0, so it really doesn't matter what's on the bottom, you're always going to get 0. Okay, so the idea is we really only need to focus on the top. We just need to know how the top creates a 0. Algebraically, that's right. We would either you call it moving it over to this side or you multiply both sides by that. Let's say we move it over, so we have our x plus 2 times our x minus 1, and we technically do the same on this side. 1, and these guys, they all create a 1 is really what they're doing. So you're left with whatever's on top here. And 0 times this, it really doesn't matter. 0 is kind of like a black hole. It just gobbles everything up. So we're just kind of left with 0 anyways. So now over here, we just have x plus 2 plus x minus 1. We can grab our like terms. Less than equal to 0. Bring our 1 over, 2x less than equal to negative 1, and divide by 2, and x is less than and equal to negative a half in this version.
That makes so much sense.
Yeah, I can show you. I'm going to show you a quick shortcut. Okay, and we could have done this really, really quickly. I'm going to jump back up to the top. If we had thought of the idea of actually just cross multiplying right at the beginning, okay, usually when we cross multiply, you think of a term, but you can essentially move an entire denominator over if you like. If we would have done that, we would have been left with x plus 2 times the 1 that was on that side, less than and equal to the negative 1 times the x minus 1 from the other side. Does that make sense where we cross to multiply? And then we would distribute. We'd have x plus 2 less than and equal to negative x plus 1. Well, let's bring all of our terms to the one side. We'd have x plus 2 minus 1 less than equal to 0. And lo and behold, we're already all the way down here without having to do any of that extra stuff. Collect like terms, 2x plus 1 less than equal to 0, and we already know that x will end up being less than equal to negative a half.
So you can still cross multiply even
Sure.
if it's the
sign
there?
You can pull a huge polynomial right over to the other side. It doesn't matter. You just have to do the entire equation when you cross multiply.
I thought you could only do that if there is an equal sign in between them.
Well, it still worked out here, right? And technically, this sign underneath is less than and equal to. Yeah. It's all the same algebraic rules. The only major one is when we're dividing or multiplying by a negative, our signs are going to are flipped when we have those types of functions.